So a vertical asymptote, meh. So this video is all about finding vertical asymptotes and finding holes. So the first thing that we do is we factor the numerator and the denominator. And then what we do is we set the denominator equal to 0 and we solve. And if the factor does not appear in the numerator, it's a vertical asymptote. That last sentence will make a lot more sense once we do some problems. So first of all, let's go ahead and factor the numerator here. Well, I know I can pull out an x, so this gives me an x squared plus 1x minus 6. And then in my denominator, I can go ahead and write this as a 4 on the outside, and then an x squared plus 1x minus 2. Now I can continue to factor that. So in the numerator here, I am going to have two binomials. I have to ask myself what adds to 1 and multiplies to -6. Well, that would be a 3 and a minus 2, so I could write this as an x plus 3 and then an x minus 2. So similarly, I do the same thing with my denominator here. I say to myself what adds to 1 and multiplies to -2. So that would be a 2 and a minus 1. So I will have the following. In the denominator, I still have that 4, but I'm going to have an x plus 2 and then an x minus 1. So I've basically done the entire first part. I have factored the numerator and the denominator. Now I'm going to set the denominator equal to 0 and I'm going to solve. So if I set this whole thing equal to 0 or try to find when it's 0, my answer would be x equals minus 2 and x equals 1. So now that we have these answers, we actually have to make sure that they don't appear in the numerator as a factor. And what I mean by that is if we have a match, for example, if this was an x plus 2, there was a match of an x plus 2 up here, then we would have to eliminate this minus 2 as a vertical asymptote. Same thing here. If I had an x minus 1 somewhere up here, then that would be eliminated as a vertical asymptote. But folks, that's not the situation here. So these right here are our vertical asymptotes. And as you might remember, the equation x equals does give us a vertical line. All right, let's do the same thing for number 2 here. I'm going to factor out my numerator here with an x. So I'm going to have an x plus 3. And then in the denominator, I'm going to have an x, and then I'm going to have an x minus 1. So let me just rewrite this down here, more space. Okay, so now I need to solve my denominator for 0 here, and so I'm going to get an answer of x equals 0 and x equals 1. And don't forget about this last step, it's really important. It says if the factor does not appear in the numerator, it is a vertical asymptote. So with the x equals 1, notice how this x minus 1 does not get repeated, does not cancel with anything up there. So this is good. However, notice how there's an x here and an x here, and actually they'd end up canceling out. And so in this case, our x equals 0 is not going to give us a vertical asymptote. In fact, it's actually going to give us a hole, but we will talk about that in a second. So our only answer on this problem here is x equals 1. Okay, we've got 2 more to try before we talk about holes. All right, so going ahead and factoring this in the numerator here, I'm going to pull out a -3, and that's going to give me an x squared plus 4x plus 3. Let me check that. Looks good to me. And then here I still have an x squared plus 5x plus 4. So let's go ahead and factor our numerator. So what adds to 4 but multiplies to 3? Well, that would be an x plus 3 and x plus 1. Now what adds to 5 but multiplies to 4? Well, that would be a 4 and a 1. So my tentative answers for my vertical asymptote are x equals minus 4 and x equals minus 1. But which one of these do I have to cross out? Well, because I've got the x plus 1 and the x plus 1, you can see that that would cancel out and make a whole. So this here would not be a vertical asymptote, so we'd cross that out. So our only answer here would be x equals -4. And notice, folks, how there's only one x plus 4, and there does not exist in the numerator. That's why we can keep it as our answer. All right, last one. So factoring this, I'm going to get adds to this, multiplies to that. How about a -3 and a -2? Because that adds to -5 and multiplies to 6. So I'm going to write that as an x -3 and an x -2. Pulling out the -4 here, I'm left with an x plus 1. And so my only asymptote is going to be x equals -1. And I have to check to see, does x plus 1 exist anywhere up here? And it does not. So it will remain a vertical asymptote. All right, sweet. So now we're going to tackle wholes. What we do when we're finding wholes is we look for a common factor in both the numerator and the denominator. And if that exists, basically solve the denominator for 0, and that gives us our whole. So let's go back and do this. So we're trying to add to 1, multiply to -6. That would be a 3 and a -2. So this here is going to be an x plus 3 and then an x -2. Down here, this is a difference of squares, so that's going to be an x -2 times x plus 2. We should be getting really good at noticing those or identifying those. Okay, where do we have a common factor? Well, that's going to be this x -2, x -2. And so the answer would be whatever would make this 0, and that would be an x equals 2. That would be our whole, because they end up canceling, and we still have an issue with our domain, but we end up still having a function around that point that creates a whole. And I'll show you in class kind of what that looks like. So again, if you have a situation where you get a cancel, in that case, you actually have a whole at that point, and you would kind of set this equal to 0 and solve. All right, so if we're thinking about what would this function look like right here in terms of vertical asymptotes and horizontal asymptotes, well, think about the fact that you would have a cancel here. So you would have a whole at x equals 2. And the function would actually just look like x plus 3. So here it is. Because these two functions cancel, or excuse me, these two expressions here cancel, it's just going to leave me with a line, and you can see that line. However, I have a whole here, and that's mainly because my domain is telling me that I can't have that 2. Even though it crosses out, I cannot have that 2 because we can't have 0 in the denominator. So that's why I have a whole, and that's why you're looking for when things cross out. So here's a summary of what we've learned so far. To find an x-intercept, you'd be setting the numerator equal to 0. You'd factor first, and then you'd find x. To find the y-intercepts, you'd set x equal to 0 and solve for y. To find horizontal asymptotes, you're going to use that cool chart. Remember how if it's like 3x to the 4th over 2x to the 4th plus 3x, you would be saying, oh, look, that's the same, so my horizontal asymptote is at 3 over 2. Remember those 3 situations, those 3 rules. The vertical asymptote, we just talked about that today. You factor your numerator and your denominator, and you look for when the denominator is 0, but if it cancels out, then it's not considered a vertical asymptote. In fact, it's considered a whole if you have a factor that cancels out both the numerator and the denominator. So I'll give you a copy of this in class, but you're welcome to write this down in your notes anyway. Thanks for watching. Have a good day.